class schedule, section Unit 5, which is an introduction to network addresses, sockets, and protocols. We're going to spend a lot of time talking about sockets, look at network address. Ready for the next section, section 6, where we're going to take a look at Java RMI. So in reading the Java Network Programming 4th edition covers network address of looking at networking. And protocol where we look at it in the context of threading. So notes, I'm actually going to look at the class notes on sockets. We'll look at the first few pages of it and a couple of examples. So if you take a look at that PDF, that's what we're going to be working on. And then there's also a couple of readings. One of them is from Apple's site on networking. It's kind of a advisory to folks that develop programs to, although they're pretty much tuned toward mobile applications. We're doing is directly applicable, and everything they say is directly applicable as well. And then the other one is discovering and advertising. It's a different form of networking in which we in a couple of different forms, and it is still widely used. Okay, so let's take a look at network addressing. An internet address. There are two different IPs, IP version 6, IP version 4. Almost everybody is still using IP version 4, in which we have a 4-byte numeric address. So in fact, the numbers that will fit into a byte is the extent numbers. So 129.219.38.79 is an example of an IP address. On the other hand, we have a domain address, and a domain address typically can be resolved to an IP, but it is a machine name, optionally followed by 0 or more domain names. So for example, at ASU, we have quay or poo.poly.asu.edu. Right? So the machine name is quay, or it is poo. It's actually an alias. Poly is in the ASU domain, and ASU is a domain within the EDU domain. So this notion of a universal resource locator, universal resource, as opposed to a URI, actually they're used largely interchangeably at this point, but some still do differentiate between the two. They specify what and where. In other words, what is typically by the tail end of a URI, and we'll take a look at where is specified by the domain address or by the IP. So an example, http:// quay asu edu :8072 SER321. This one actually is inactive. /index.html, and then hash mark or £, chapter 1. So there are several different components that exist within this URI, and the most common ones are, first of all, the protocol. In this case, it's the HTTP protocol, as opposed to HTTPS, which is secure, FTP, file transfer protocol, SSH, RMI is another protocol, remote method invocation, mail to file. There's a file protocol which specifies a file in the local file system. ORB, I mentioned Corba before. Corba defines an ORB protocol. So this whole notion of a protocol is something we're going to look at in more and more detail. But essentially, you can consider a protocol to be nothing more than a set of rules for engagement, meaning that we have two different components on the internet. They're going to do some communication and some synchronizing, communicating and synchronizing. The protocol that they use are the rules that they use to determine how they talk to each other and when they talk to each other. So, for example, a protocol may say, well, the client initiates the connection with a request that has the following format. The server responds from that request to the client with a specific message of a specific format, and so forth. So it defines, a protocol defines who is saying what to whom, and what they're saying, or at least the format of what is going back and forth. And HTTP is a protocol that's been around for now quite a while, that has been extended over time to incorporate all kinds of new capabilities. So the internet address then can be an IP, or it can be a domain name. In this case, it's quay.poly.asu.edu. There's a port number, in this case 8072. So ports, if a port is not mentioned, then for a given protocol, there's typically a default port. So you probably know that HTTP, the default port for HTTP is 80. So if I don't mention any port in a URL, an HTTP protocol URL, then in fact it defaults to port 80. That doesn't mean that's the only port that can be used. So we can bring up an HTTP server and have it listen to a different port, or even listen to multiple ports for that matter. So the port number can be specified. And typically there is a default, at least for the popular ports. Port numbers can be numbers. I forgot what the maximum range is, but under 1024, all of those ports are assigned to well-known protocols. And above that, in fact, you can pretty much use whichever port you choose. And then there's a file part, SER321 index. So that's the file part that's specified. And then an anchor within that file. So in fact, we have the ability to burrow down, in this case with HTTP protocol, to specify components within a file, or a portion within a file. So the general form is protocol : / user at host : port path ? We can have a query, and then we can also have a fragment. So in fact, there can be query with parameters associated with it as well. So as I said, the general format is actually fairly complex, and we're not going to use all of it. We're only going to use a very small part of it. But nevertheless, that's the notion of a URI or a URL. So network addressing. Let's talk a little bit about ports. What is a port? Well, on any given machine, one can identify thousands of different ports and communicate on those ports as supported by the underlying operating system. And you can think of a port as an airport or as a seaport, meaning that it is a place where an exchange takes place. Typically, it's some kind of communication or some kind of quote-unquote commerce that takes place, internet commerce as an example, where in fact the communication, in this case, typically from one machine, but it doesn't have to be. It can be from within the same machine, and often it's implemented differently if it's from the same machine, communicates with some other active program on that machine. So a port is a 16-bit integer, and as I mentioned already, ports less than 1024 typically reserved for the system. So a socket is kind of like a plug. Sockets have two components. They have an internet address and they have a port. So when you create a TCP/IP socket, we'll talk about TCP/IP in a little bit more detail later on. In fact, you have to specify both either an IP or a domain name. and together with it a port. So a connection is essentially establishing a linkage by means of using a socket to establish a linkage between really two active programs, a client and a server typically, but it could also be peer-to-peer communications. And the connection may last for several communications in both directions, or it may only last for one communication. And then again, the notion of a protocol, agreement of what, when, and how communication is to take place between client and server, or these two communicating entities, communicating programs, executing programs. And I think, let's see, SMTP is probably the only one that wasn't there before. That stands for Simple Mail Transport Program. FTP is File Transfer Program. Telnet, I don't know what that stands for, establishing remote logins. Telnet was widely used before security became a concern. It is an unencrypted communication mechanism to establish a terminal session on a different machine. We now most commonly use SSH, Secure Shell, which actually has its own protocol. Sockets, right? Again, a socket is um, an internet address together with a port. So you can consider that to be the important information that's necessary to make up a socket from both ends. Sockets have been around for a long time, and probably beginning with Berkeley Unix, BSD, in the 80s, and they were initially used for inter-process communication, meaning that we have two different programs running on the same machine and they want to communicate with each other. Then in fact we use sockets in order to do that. Sockets are supported on virtually every operating system. I'm not aware of any that don't, including all of the mobile operating systems, and surprisingly, real-time operating systems that run on very minimal devices that are embedded in maybe a mechanical system very commonly support sockets and networking. So there are three different flavors of sockets, and we're going to focus on the middle of those two. The datagram is a bare socket that is typically used for speed. There is not a lot of overhead associated with a datagram, and in fact, with a datagram, you have an amount of information that you want to send from one machine to another machine. There's no acknowledgement provided that it got received, and there's no sequencing. So if you send two different datagrams from a client to a server, for example, there's no guarantee that they're going to get there in the same order. And so consequently, it's something for a quick shot. So datagrams, I don't mean to say they aren't useful. They're very useful. For example, if you're programming a distributed game and you want to let other participants in that distributed game know the current state of a given user, you may use a datagram and just shoot information to the other users or the other players. And you really may not be too concerned. Well, they may miss one of the messages, or they may even arrive out of sequence, but that's okay, because over a period of time, that'll all be made up for. Stream sockets, on the other hand, TCP/IP, Transmission Control Protocol, and Internet Protocol, stream sockets are session-based, meaning that a connection is established between a client and a server, and that connection may exist over a period of time. Within a connection, there's a guarantee that the order of sending and the order of receiving are the same, right? So packets don't get out of order, even though they may be routed in many different ways, and one may take much longer than another to get there. They are going to arrive and be given to the server and or client, the receiver, in the order in which they were sent. And there's also error checking that exists as well. And then the other thing about stream-based sockets is that there's an unlimited data size for the packets, right? Very different with datagrams. And then raw sockets is kind of an interface to a low-level set of protocols, and they typically are not commonly used in application development. It's probably the right way to put it, but they actually can be used to develop other protocols. Okay, so now this is kind of a scenario for sockets. I'm not going to go through this at this point. We'll come back to this when we start looking at creating server sockets, accepting and clients as well. Again, actually, in the session on serialization, we looked at the different kinds of input and output streams. Not only are these input and output streams the way we communicate to files, to and from files, but it's also the manner that we use to communicate over sockets to a client or to a server. Right? And again, if it's an object stream, then in fact it's appropriate for primitive data as well as for serializable objects within Java. On the other hand, if we expect the client and or server to have if we expect the distributed communications to be done by multi-language participants, like we're going to do this semester, then in fact using an object stream isn't appropriate. So if I've got a C++ client, it's not generally going to know how to deserialize an object that was serialized by a Java server. So in fact, in that particular case, we typically use a data stream where we have byte arrays that are passed back and forth. So I do want to take a look at some of the examples in this example Java simple sock.jar. But before we do that, I want to take a look at another perspective of networking, and this is actually from the Apple site. Because this actually gives a very good set of guidelines for developers to maybe more cautions than anything else. But it shows you a very typical topography or topology for networking today, where the internet is made up of physical connections, which you can see in the lower left-hand corner of this. It's also made of cellular connections and also Wi-Fi 802.11, as well as satellite. So it really has not been that many years since it was only hard connections, and then it evolved to include satellite connections, and now Wi-Fi and cellular. So a smartphone can use the internet through its cellular connection if there's data that's provided by the service provider, and communicate without recipients of information even knowing specifically the media that's used to communicate the data. So there's lots of different ways that it's done today. And let me see if I can boost this up a little more, maybe a little bit more readable. So again, this is actually on the a reference to this in the detailed class schedule, but it makes the point that I think it's very important. So if we're communicating between two different components of a distributed application on its way from the user to an internet server, the user's network data passes through anywhere from 1 to dozens of physical interconnections, right? And any one of which could be high speed, meaning almost 40 billion bits per second, or 300 baud, meaning 300 bits per second. Right, so there's a huge disparity in terms of the speed of communication, and that's why I say, depending upon routing, and even with a connection-based protocol, routing can differ for different messages, and that difference may make a huge difference in the difference between in the lapse rate, the difference between the send time and the receive time. Uh, right, so worse, at any moment, the speed of a user's connection to a server can change dramatically. Right, so sometimes in the middle of communication, um, a smartphone, a wireless device may move from one tower to another tower, or if you're taking your laptop around your home, all right, your connection and the communication between your laptop and your router may take significantly more time when it's further away from the router than when it's closer to the router because of the difference in signal strength. And with error correction and detection and correction, that may cause resends and all sorts of overhead that increase to the lapse time. So there are some guidelines. Transfer only as much data as required to accomplish a given task. Avoid timeouts. Design user interfaces that allow the user to easily cancel the transactions, to cancel an internet-based transaction that's taking too much time. Handle failures gracefully and expect that they're going to occur. Although communications are very good, they are not perfect. That is definitely the case. Degrade gracefully when network performance degrades. Choose APIs that are appropriate for the task. So we're going to get an introduction to actually a couple different levels this semester, but the reality is that there are lots of different technologies that are available, and they span the spectrum of being very low level technologies as opposed to very higher level. And some tasks are more appropriate for low level communications, downloading, for example, and other tasks are appropriate for higher level communications, HTTP as an example. Design your software carefully to minimize security risks. So I think there's actually some very good suggestions there that can kind of give you a better context for the types of communications that exist over a network. So now let's, I don't know if I do anything about Bonjour. So Bonjour is a mechanism that allows for most of the communications that we're going to look at this semester, all the communications we're going to implement, are for what are typically called well-known services, meaning that the client knows the IP or has the ability to go someplace that it does know to find the IP of the server. Right? Well, that's not always the case. Right? If you think about taking a smartphone to it doesn't matter where it is, into a mall, into a new place of business, and you want to print something or you want to use some local services there, the application running on the phone has to discover where those services, what services are available. And Bonjour is one of the technologies that's available in order to do that. And don't want you to think this is Apple documentation, but it's not only implemented on Apple, it's implemented elsewhere as well. So there's the ability to discover what's available by doing a multicast and waiting for folks to reply, folks meaning potential servers to reply. In other words, I don't know the specific IP that I want to communicate with, but here's a description of the service that I want. So any servers that can provide that service, please respond. So Bonjour provides a new kind of capability that is becoming increasingly important in mobile networking today. And I'm not going to go any further into it than that. So now let's go back to our example here. If you would download Java simplesock.jar, and let's go through at least two of the programs. We're not going to do the datagrams today or the socket and server socket, but I do want to take a look at, just to give you an introduction to converting from a IP address to a domain address or between the two. And also some of the components from a UI perspective. User interface technologies have advanced incredibly, and they are very much aimed at network connections. So we'll take a look at something that's actually been around in Java Swing since it began. That makes it very simple to render. So in other words, the web rendering engine is available in controls in almost every UI set of components, the UI frameworks that exist. So let's go ahead and switch. I'm going to go to LX terminal. So I'm running on the Linux Debian, and I'm in my example program or my examples folder. I've got a subfolder called sockets. And in sockets in particular, let's take a look at Java Simple Sock. Make sure minus RF, I've been playing around with it. First thing to do is to take a look. So if you haven't figured it out yet, sorry, I've been using LL, and I think I mentioned it in the first video. LL is a shorthand for ls-l, and ls-l, one can create an alias. LL equals ls-l, and in the bash rc file, in the bash rc file in your home directory, you will find this alias defined. So there is a default .bashrc. All right, there's a dot in front of it, so this is the right name for it. Home directory .bashrc. You can put other stuff in here, and that's what it's there for, to personalize your bash environment to whatever you want it to be. But it's commented out when a new user is created, there's a default .bashrc that's placed into that user's home directory. You have to go in, if you want to use LL, you have to go in and remove that comment. The comment is a hash or a pound sign. Just delete that with an editor, and then start up LX terminal again. Start up a new LX terminal, or do source space .bashrc or tilde slash .bashrc, depending upon where you are, and it'll reread the .bashrc, and then LL will do what you want it to do. So after extracting simple Java sock, you end up with a build.xml and a source. So to find out what the targets are, ant and build. So this not only tells the targets, but it also tells there are several different programs that are in here. We're going to take a look at get IP, get name for IP, and simple browser today. So let's build. And now let's take a look first at converting from an IP to a name. So Java-CP classes, ser321.sockets.get name for IP. And let's use 129.219. Well, I don't remember what it is. 40.57. 40.47. Yeah, I got it. So this tells me that the IP 129.219.40.47 is the IP for the domain name quay.poly.asu.edu. Right. So there's another one. There's the ability. These are really simple programs, and they're just using a couple of simple facilities out of one of the classes in java.net. We'll take a look at that in a minute. But in fact, I can go the other way as well. So I can say get IP for poo.poly.asu.edu. And it tells me that the exact same thing. Poo and query, it's an alias for the same IP, 129.219.40.47. And here you can see it's broken up as integer segments in different bytes that exist. So this works for all kinds of stuff. www.google.com. All right, and the interesting thing is going in the other direction with google.com. 216.58.192.4. All right, doesn't tell me it's google.com, but let's just, for the fun of it, see if it works backwards for that guy. All right, so you can see 216.58.192.4 in both directions, NUQ04S29, so on and so forth. For me, www.google.com resolves to 216.58.192.4. It may not for you if you're on the other side of the country. It probably doesn't, as a matter of fact, even if you're in a different town. But in fact, for me, that's where it is. Okay, so this provides us the ability to go in two different directions, and let's take a look at the code for these. Get name for IP and get IP. So if you look in the source directory, I've already got one of them up here. All right, so in the source directory, there are several different programs. Datagram, so we'll take a look later on at datagram, sending and receiving a datagram. Get IP and get name for IP, and simple browser. So we're going to actually take a look at those three right now: get IP, get name for IP, and simple browser. So get IP uses right inet address dot get by name, right, args of 0. So args of 0 is the command line argument, dot get address. Right, so it gets the address associated with the name, right? So let's take a look at inet address, and if you haven't already bookmarked it or downloaded it, I encourage you to do it. I'm going back to the home page's resources page, and down here under the section on Java, there is the Java API documentation for Java SE. So if you don't have it bookmarked, this will work. If you don't have it downloaded, you can actually download it in HTML form, so you have it locally on your own machine. So if we look in the class, in the package, java.net, we'll see that not only are there several different interfaces, but there are also several different classes. Some of these we're going to be looking at quite a bit during this semester. But you see there's an inet4 address, inet6 address, and an inet address. There's the inet address, multicast socket, net permission, proxy. We're going to look at server socket and socket, socket address, URI and URL, quite a bit this semester as we go on. So inet address, no constructor for it. Notice that it's serializable, and it has two subclasses, inet4 address and inet6 address. So if we want an inet address and we don't know whether it's a 4 or a 6, then this would be the way to do it. It gives an explanation of what an inet address is, the two different unicast as opposed to multicast address types. And let's go back up and take a look at the methods in particular. Some of the methods are static methods, meaning they're class methods. The class methods you can call by saying inet address dot. So inet address dot get all by name of a host, and it'll return for you an array of inet addresses. Get by address, right? So that's one of the ones that we're using. And get by address returns an inet address object given the raw IP address. Right, the argument is in a network byte order. Highest order byte is the address in address of 0, byte 0. Right, so in this particular case, we are using um, inet address get by name args of 0. So that is our entire um, domain name, right? Get by name, so that's a string name, and then we're doing the get address on it. Is that the one I'm looking at? Oh, no, it's not. Get by address, and we are looking at get by name. Get by name, there it is, string host name, right? So this returns for us an inet address, right? Get by name, so we have a string host name, poo.poly.asu.edu, and it'll return an inet address object for us. And then what we do with that inet address object is to get its address, and the get address returns for us either 4 or 6 bytes. Get address returns raw IP address of this inet address object. The result is in network byte order, highest order byte. Right? So that's why when I printed it out, I did each of the different bytes as well, and that's done down here. For int I equal to 0, less than 4, I plus plus doesn't even go to the length because I know it's going to be a 4, and it prints out the different bytes. Okay, so let's look going in the other direction. We've already executed it. Get name for IP address. Again, we're doing a similar kind of a thing, but this time we're bringing in from the command line an IP address, right? 129.219.40.47, for example, and using string tokenizer, separating it by dots. String tokenizer picks out the different components, delimited components, and the delimiter in this case is a dot. You can use a scanner as well. So I'm going to get it into a byte array of 4 bytes, what I'm calling IP. So this separates it out. And looking at it as an integer, in fact, if it is an integer, then in fact we have to subtract 256 to get it to the, if it's greater than 127. If you look at the values that are available in an 8-bit byte, you see that this is an operation that's necessary in order to do it. Inet address, get by address, the IP array, and then get the host name from it, right? So we get an inet address object, and then we tell that object to give us its host name, and that will give us the domain name for, or the host name for a given IP address. So now the other one that I haven't executed yet, I want to show you it as well. And this is, I think it's the default, we'll find out. This is an example of a swing component. Yeah. So I don't think I can boost it up any. A swing component, which will, it's a panel that renders a URL. So it's essentially, I call it a simple browser. So in fact, we can use other ones. Let's look at my.asu.edu and then hit display. The rendering is a little different than what you get for the login page, but that's all right. I think you can see the idea here. So any URL that you want to give, enter the URL and hit display. Hot links mean nothing here. You'd actually have to go in and handle mouse over events and handle click down events as well. But let's take a look at the code for it. That's the first example of using swing. And This is a simple browser class. There is a constructor that takes a URL string, and notice that we have a private JText field. So the text field is this control. All right, so an object of the class JText field. All of the Swing components, Swing GUI components, begin with a capital J. This text field actually, the reason they do that is to differentiate that it was done, is to differentiate from another GUI framework called AWT, Advanced Windowing Toolkit, I think, which turned out to be pretty resource consumptive, that was available initially with Java. JText field is that text field. We also ought to have a button here someplace. Must be we don't keep the button. We need to refer to this after the constructor, so that's why it's there. Same thing with the display pane, but we don't need to refer to the button. So we create a menu bar, and the menu bar we're going to put in a display and an exit. So the display does the exact same thing that pressing the button does. And I want to do that. So there's our file menu. We have a mnemonic for it, so there's a shortcut for it, which means that if I do Command or Control F, depending upon the system, it'll invoke the file menu. So let's see, which one is it? Command F? Nope. Control F. Option F. Option F on Linux. Right, and it tells me which one it is, and then I can use up arrows and down arrows and return to select. Tooltip. All right, so there's an example of, if you mouse over, you can see a little tooltip comes up. Use the file menu to display a new page. So that's set tooltip, and we have two different menu items, a display menu item and an exit menu item, and this iteration goes through and creates those menu items and adds them to the menu. Then the menu that's now been completed gets added to the menu bar. So dealing with GUI components is very similar to dealing with about anything else. You create these objects and then you put them into a panel or into a pane. I guess I didn't mention this class extends JFrame, which is the root class for a window object in Swing. I had a tree. There's no tree in this one. Display pane is a new JEditor pane. Display pane.set editable. So the JEditor pane is this entire area in which we're displaying. Let's go back to. All right, so this entire area is the JEditor pane, and it is what has the ability to display a URL. We're saying it's editable. It's not editable, so the user can't change what's in it. We actually are going to throw it into a scroll pane, so if it renders a page that takes more space than what's available in the window, it'll give us scroll panels and so forth. So you can see here's our the creation of our button. In order to handle button clicks in Java Swing, actually in AWT as well, or menu item selections, we implement an interface called Action Listener. So you can see up here it's implemented by this class. And then we register ourselves as a listener. So menu item dot add action listener of this, which says the object that I am currently creating, I'm in the constructor, is going to listen for events, action events, which are events that get generated when a button object gets clicked or when a menu item gets selected. So you can see that actually this part of it is not for the button, this is for the menu item. And then down here when I create the button, new J button with a display in it, up.action, right, it's up, action listener of this. That's what causes a callback when someone clicks the button display. So if you look at the interface, action listener, implementing action listener requires the class to implement a method whose name is action performed and takes as an argument the action event. Right? So that's the reason that this method exists in here, public void action performed, and this is a mechanism to find out if the event's action command is exit, right? Meaning that the file exit menu item has been selected, then do system exit of 0. Otherwise, if the action command equals display, and in this case it could either be that display, or it could be this display, because the text that's in a button and the text that is in a menu item, right? I'm pointing at a menu item right now. Those are by default the action commands. Unless I change them, I can set the action command to whatever I want up here in the constructor. But if I leave them as they are, then they just turn, if I don't explicitly set it, then it's whatever the text is in the item itself. Right, so if I get a display menu item selection or button click, then the display pane, set it to the page, a new URL, and the URL I get without doing any checking, unabashedly, totally unreliable code, URL string field.getText. Right, so the URL string field is the name of this JText field element, and I get the text out of it, which in this case is going to give me a string http poo poly asu edu ser321. I convert that into a URL, and I tell the display pane to go ahead and set that page. In other words, render, go and fetch that page and render the HTML that you get from it. And that's how we ended up getting the home page for the class displayed there. Okay, so this is as much about swing and GUI controls as it is about networking, but understand that the implementation, Java's implementation, or in this case Oracle, or actually it was Sun that implemented it, of the JEditor pane included the ability to do a network connection, all right, to go to a server as specified by a URL, to do an HTTP request in this case of that server, and then download the result and render it inside the page. All right, so that's a pretty smart control, able to do that. And of course, we could actually complete, as you can see, I end up with each of the hot links, mouse over each of the hot links is an indication that in fact the rendering of it is smart enough to be able to tell us when we are selecting a hot link, and even tell us the URL that we're to go to, as long as we handle the appropriate events. I didn't do that in this one. There's no sense in doing that. Okay, so that's the other example that I wanted to go through. Simple browser, get IP, and get name for IP. So let me go back to this one. So we have covered INET address, which is a class that encapsulates a relationship between an IP and a domain address, and shown it by a couple of the methods, a few of the methods that are in the INET address class. And we've also looked at the URL. We didn't actually even bring up the Java doc for URL, but it encapsulates a web resource to create a Java rendering of what a URL is and how it can be used. Okay, so I'm going to leave it at that for today. Again, this has been the section number 5 on the detailed schedule, which is an introduction to networks and sockets. There is not a specific lab exercise for this one. Currently, you should be working on the serialization exercise, which is to use JSON. So next time we'll talk about Java RMI, which is a client server technology that's based at the object level.